Hi there, welcome back to my channel, and in this video I want to take you through limits points of a set. In our previous lessons we dealt with isolated points, neighborhood, and the others. If this is the first time you're on this channel, kindly subscribe and please watch this video to the end. So what is limit point of a set? A limit point of a set. So within an interval, right? Within an interval, if we identify any point so that when you take a delta neighborhood, we identify other members of the set, other members. So let's say at least one member of the set. It should be at least. We identify at least one member of the set. Then we say that the point is what? A limit point. That is all. So a limit point is simply that if I have any interval, say AB, right, and I choose randomly a point from this AB, if I find a delta neighborhood around this AB, I should get the at least one of what other members within that interval. Otherwise, it's an isolated point. Okay. So let's see. I have, let's say, a point 1, 2, 3, 4, right? So my interval is from 1 to, let's say, 3 open. If I identify any point here, say S naught, right? S naught will be a limit point provided that when I take any delta interval, right, any delta neighborhood around this x naught, I'll identify other members of what? Of the interval within it. So if I find the delta neighborhood and I still don't get any other members, then x naught will be said to be what? Isolated. So isolation. If it's not a limit point, then it means that it's been what? Isolated from what? Our set of what? Numbers. Okay. So now let's see. There are some fixed rules for limit points or some fact, right? So no finite set, no finite set has a limit point. No finite set has a limit point. That's one thing you should take note. What is a finite set? A finite set is simply a set which ends, or so you can have, normally a finite set is represented as this with a curly bracket. Okay, you can have 1, 2, 3, 4, 5, then you close it. This is not an interval, not an interval, right? Take note. There is a difference between an interval and what? A set this way. Okay, so an interval will start from what? 1 to 5, like this. This means that a set of what? 1 less than x less than what? 5. This interval has 1, it has what? 1.1, 1.2, 1.3. It's infinite. Okay, the numbers within 1 to 5, you can have bunch of what? Rational numbers densely packed within this. But when I give you this set 1 to 5, it's just 1, 2, 3, 4, 5. There is nothing between 1 and 2. It's what? Finite. Okay, so the rule is saying that the limit point of what? For every finite set is what? 0. Sorry, it doesn't have a limit point. That is it. It's not 0. It doesn't have. So no finite set has a limit what? Point. Take note. Now let's prove this. To prove this, as I said for the definition for limit point, we when you take a delta neighborhood around it, delta neighborhood, right, around any point choosing as a midpoint, then we should find at least one of what the other members within. So now let me choose something like what? 2. So if I choose 2 as the limit point of this finite set and I take my delta to be what? 0.01, right? You should take as small as possible. That is 0.01 is very, very good. So you just get your interval to be 2 minus 0.01, comma 2 plus or 0.01. This should give us what? 2 minus 0.01 will be 1.99. So 1.99, comma 2.01, right? So this 1.99 and 2.01 within this interval, right? We can we locate any other members here? Because here within 1 and 2 there is nothing here. They are discrete points. Take note, discrete points. So you realize that within 1.99 to 2.01 there is no number here which falls in this range. Therefore, for a finite set, no matter what you choose, no matter delta you choose, you will never find out other members within that interval. So let's see. The next one is an infinite set. An infinite set may or may not have a limit point. May or may not have a limit point, right? So an infinite set may or may not have a limit point. That is it. So what is an infinite set? So the first one we dealt with was a finite set, right? So this case, let's consider an infinite set. And I said a set is covered by what? A curly bracket, okay? So you have something like, let's say 1 out of 2, 1 out of 3, 1 out of 4 towards infinity. You represent it with 3 dots. And we are saying that this particular set may or may not have a limit point, right? May or may not have a limit point. So with this interval, let's assume that the limit point is what 0, right? So we can take a delta, let's say 0.01, and we are going to get what 0 minus 0.01 comma 0 plus 0.01, right? So we are getting our interval to be 0.01 comma 0.01. Within this interval, negative, this is negative. Within this interval, can you identify any members here? This set is starting from what? 1 out of 2. So starting from 0.5 as the biggest number in this set. But as it's moving forward, you can reach a point where you get 1 out of what? 100, right? 1 out of 2000, right? And they will all fall within this range. They will fall within this range because you are going to have something like so here is 0.01, and you can, if you are having something like 0. Let me say 1 out of, 1 out of 100 will give us 0.01. Yes. So if you have anything like 1 over 101, 1 over 102, it will be less than what? 0.01. Take note. So surely you have what? Members of this falling here. Therefore, 0 is what? The limit point. So an infinite set may or may not have a limit point. So such this example, it has a limit point. Okay. It has a limit point. So randomly, let's take some examples here and solve for limit points. So 1, find the limit points of the interval 0, 2, right? So if they ask you to find the limit points of an interval, you just have to choose a random number, right? So you can start with for the endpoints, the smallest endpoints, like that. So now let's see. When I have 0 as my center, okay, if I choose the limit point to be 0, if I choose it to be 0, then I will take a reasonable delta, but I say it should be small as possible. So for delta equal to 0.01, then I'm going to have 0 minus 0.01 close brackets, 0.01 comma 0.01 plus 0, right? So this gives me negative 0.01 comma 0.01. In this interval, do we see any member of this within here? Do we see any member of this here? This starts from 0.000001. Like there's a dense number here. Whenever you have an interval, you say s is greater than 0, right? Greater than or equal to 0, but less than or equal to 2. This means that the numbers within this is dense. You can have 0, 0.00, 0.000001, all falling within this interval. So meaning that this interval you can get what? 0 points. Within this interval you can get something like 0.01001 within this interval. And we can also identify that one too here, right? You can also identify that. So meaning that 0 is indeed a limit point of what? This set. Now take note. Whenever a set contains all its limit points, we say that it is a closed set. We say it is a closed set. Okay, so a closed set is a set which has all its limit points contained in what the set, right? So that every point in it is a limit point. Okay, so even with this example I gave here, now it's a closed set. So let's see, when I take 2 as what, 2 as my limit points, you realize that I'll get, using 0.01 delta, I'll get something like 1.99 comma what 2.01. Within this interval I'll surely have what members here, right? So meaning that when a set has all its limit points, it means that the set is not a closed set. So every closed set will have the limit points being any set and being any member of what the set. Take note. So this is the lecture on um limits of points, limit of a set here. So thank you for being with me in this video. Kindly subscribe so that I get useful contents like this.